We're starting a new module, and this module is devoted to solving equations. Let's start with the rational equations, which is the point of this topic. Okay, so the definition of a rational equation is a rational equation is any equation that has a rational expression. So when we start dealing with equations, okay, so statements with equal signs that have fractions, okay, we're dealing with a rational equation. So here's two examples. 1 over x plus 1 over 5x equals 12. That's a rational equation because it has fractions and it's an equation. Same thing here. X over x squared minus x plus 2 over x squared minus 1 equals 1 over x cubed minus x squared. That's a rational equation because it has fractions and an equal sign. If you think back, we've dealt with simple rational equations before. Okay, so for example, we have solved in the past equations like x over 3 plus x over 2 equals 4. And I know we've solved this equation because technically speaking, this is a linear equation since it has x's only to the first power. Okay, but it's also a rational equation because it has fractions. All right? So let's recall how we solved this equation to help us understand how we're going to solve all rational equations. Okay, so remember, to solve equations that have fractions, the strategy was to clear the denominators using the LCD. So for example, in x over 3 plus x over 2 equals 10, we know that the LCD is 6, right? The smallest thing that both 3 and 2 go into is 6. So we can multiply each side of the equation by 6 to help reduce our fractions away, to help clear the denominators. And if you want, if it helps you, you can think of this as multiplication by 6 over 1. Okay, that way you remember that the 6 is actually in the numerator. Once we multiply by the LCD, we reduce. For example, 6 over 3, right, since the 6 is in the numerator, 6 and 3 reduce to 2. Same thing on the next fraction, since the 6 is in the numerator, 6 and 2 reduce to 3. And then we just have 6 times 10 here. That's easy to calculate. So finally we do our multiplication. 2x from the first term, 3x from the second term, 60 on the right side, combine like terms, divide, we end up with x equals 12. Okay. So the same general strategy of multiplying by the LCD to clear the denominators will work with rational equations that are more complicated, with x's in the denominator. Right, so let's examine how that works. So here's our main idea. It's exactly what we just talked about. To solve rational equations, multiply both sides of the equation by the LCD to clear the denominators. Okay? So we're going to take equations that have more complicated fractions and hit everything by the LCD in order to get rid of the denominators. All right? After we clear the denominators, then we'll have some equation to solve, maybe even a quadratic equation, but that's okay. We learned how to handle those in the last module. Okay. Couple things to remember. When you're finding the LCD, if you're just dealing with numbers, like in the previous example, the LCD is going to be another number. But if you're dealing with polynomials in the denominator, you want to factor all the denominators. And then to build the LCD, you take each factor the most times it occurs in any single denominator. And then one last remark, be aware of extraneous solutions. So sometimes when you're solving rational equations, you'll get a solution that doesn't actually check out in the original equation. Okay, and we'll talk about that in the examples. So let's look at a quick example to help reinforce the main idea of this topic, which is clearing denominators by multiplying by the LCD. All right, let's solve the equation 5 over m squared plus 3 over 4m equals 1 over 8m. Right? If we look at all of the denominators in this equation, we have an m squared, okay, a 4m, and an 8m. If we want to find the LCD for these denominators, we need an expression that's bigger than each of them. Okay, we need an expression that contains each of them. So between 4 and 8, we need an 8. And between m, and m squared, we need an m squared. Okay, so that's why we say that LCD is 8m squared. So we're going to multiply everything by 8m squared to clear the denominators. And again, you can think of the 8m squared as 8m squared over 1, if that helps you remember that the 8m squared is in the numerator. Okay. So when we take the original equation and we hit everything with the LCD, a bunch of stuff reduces. That's the point of multiplying by the LCD. All of the denominators should reduce. Okay. So if you look, in the first term, 8m squared times 5 over m squared, the m squareds are going to reduce, leaving you with just this 8. All right. In the second term, 8m squared over 4m, the 8 and the 4 are going to reduce to 2, which is why we get a 2 left. And the m and the m squared are going to reduce to m, which is why we end up with 2m. And then finally, 8m squared over 8m, the 8's reduced to 1, the m squared over m leaves you with just m. Now we have to multiply everything out. We had a 5 and an 8 left here. They have to be multiplied. 5 times 8 gives you 40. We had a 2m and a 3 left here. They have to be multiplied. 2m times 3 gives you 6m. We have an m and a 1 left. They're multiplied. At this point, we're back to a linear equation. We've been solving these since we were in diapers. Okay, you get your variables on one side, your number on the other, divide, and you end up with your solution m equals -8. So all the work in this example was done in two spots. One, finding the LCD. Okay, you have to be able to identify what the LCD is. Okay, and then the second piece of real work we did was actually reducing when we multiplied by the LCD. That's how all these problems are going to work. You're going to figure out what the LCD is, and then you're going to multiply by it so that all your denominators get cleared out. Alright, so here's our first example. The instructions say state the type of equation and then solve the equation. And the first equation we're given is 8m over 5 minus 3m minus 4 over 2 equals 5 halves. Okay, so there's two key features you should notice about this equation. First of all the variables have exponent 1, and there's no variables in the denominator. So in all technicality, this is a linear equation. Okay, but we do have fractions, so it's also a rational equation. Because it has those fractions, the way we're going to solve this is by first clearing the denominators. And because it's linear, after that we're going to isolate the variable using reverse operations. So now that we have a plan of action, right, now that we understand our equation and how to attack it, we have to go ahead and carry it out successfully. In this particular equation, if I want to clear the denominators, I have to find the LCD. My denominators are a 5, a 2, and a 2. That makes it pretty clear that the LCD is going to be 10. So I'm going to take this equation and multiply both sides by 10. So this is what it looks like after I multiply each term by 10. Now you have to reduce. Okay, remember this 10 is in the numerator. If you want, you can think of it as 10 over 1 to help you remember that. But the point of multiplying everything by the LCD is because it reduces the denominator. 10 divided by 5 leaves you with 2. Same thing here. This 10 reduces with this 2 to leave you 5. And this 2 and this 10 reduce to leave you 5. Okay, so in the first term, I end up with a 2 and an 8m left over that I need to multiply. In the second term, I end up with a 5, a negative, and a 3m minus 4 that needs to get multiplied. And then in the last term, on the right side, I end up with a 5 and a 5. So let me write what I have after all the dust settles. So just like I said, here we get 2 times 8m. Here we get a negative 5 times 3m minus 4. Okay. And then on the right side, we have 5 times 5. So I'll clean this up. This is 16m. Distribute out my negative 5 minus 15m plus 20 equals 25. Now this is clearly a linear equation because all we have is a variable to the first exponent, to the first power. So I'm going to collect like terms and then isolate my variable. So let's run through those steps quickly. We had 16m minus 15m, so we collect that to 1m. Plus 20 comes down, 25 comes down. Subtract the 20 to isolate the variable, and we're left with m equals 5. And this is our answer. So that's it. We're done.